I welcome to Fundamentals of Artificial Intelligence. We are having our first interactive session today. I have with me the three TAs in this course. I have Hirok here, Hirok this side, Nilav, and I have Masruddin, who helps with the administration of the course. Now we have got some feedback from you on the link that we have shared. It was really interesting to note that a couple of learners have liked the way the course is going. Few of you have raised certain queries that we will try to address in this session today. So we will take queries as it comes on the screen. Here, Hirok will try to read the queries for me, and we will see how many of them we can address today. We will be live for almost an hour, and that is the plan. Let us take the first question. What is the first question? So let us take the first question here. Anybody has a question there? So there is a delay. Okay, okay. So that will go live. Okay, good.
What is the last date for registration of the exam?
For these interactive session, we will try to address only questions related to the course. In terms of questions related to administration of the course, I would request you to kindly look up the SWAM web pages where it is clearly mentioned dates and different deadlines for your assignments. One of the queries that has been there are either in the Google sheet that has been shared with you, or as feedback on the YouTube videos that we have circulated, is about the material being made available. So now we have got clearance from the NPTEL. So all the material pertaining to this course up to the coverage that we have done would be uploaded very soon in the web. So any other questions? So let me take some questions from the sheet that we have circulated before. So there is a question there from Jagannath, who said, how is AI different from data science? Now, as you know, data science is a more broader term. It's about mining data to find out patterns, associations, and then try to answer questions. Like, let's take an example from the marketing that you do on the web today. So if you are using an online site like Myntra, where you buy a kurti, and someone has brought jeans, so the moment you buy a kurti from Myntra, the program prompts you and says that someone who was interested in kurti was also interested in these jeans. Now that's data science based on the way the behavior of users has been on that website. They will try to mine the association between kurti and jeans and put it in front of you. Whereas what we are doing in this course called artificial intelligence is a more broader term. It's about one of the uses could be data mining, which is about trying to find out associations or links between data. But what is more important here is we are more interested in understanding the fundamental concepts of how to build systems that behave intelligently, in the sense that if you remember when I was taking this first introductory course, I told you about any intelligent system could be looked at in 4 dimensions. Either you would be looking at thinking rationally, or you'd be looking at thinking humanly, or you'd be looking at acting rationally or acting humanly. So we are more concerned about recreating this is 4 different systems, one of these 4 different systems, when we are dealing with any form of computation here. And that is how data science could be some fragment of AI, but AI is a more larger term that covers more things. And then there was a question about how to prepare for GATE exams. I am very sorry, I sincerely apologize to you. I am not the most competent person, but on a serious note, this is not the platform to answer that question, and so I would ignore that for the time being. Then there is some appreciation for the way the learning is going. Thank you for that. And then there is a question on would artificial neural networks be covered? That's by Shrutika. So Shrutika, yes, we will do artificial neural nets in some time to come, when we will be doing learning within our module on machine learning, and we will definitely cover ANN in this course.
It's 15:45.
So the next question on what are the future scope of AI, and I should proceed the journey in this career, or please guide me. So as far as guiding you, I would say that if you do this course, you can find your own way. As far as the scope of AI today, if you look at the introductory video itself, you realize that somehow artificial intelligence is slowly becoming part of our daily living activities. Whether you talk of your smartphone, whether you talk of your car that you are driving, and there are interesting cars which advise you when to change the lane, all of these is part of AI. Or you can look at any simple mundane system like your washing machine that decides on the more number of spins based on how dirty your cloth is. That's part of AI. So AI has a wide-ranging scope and perspective in terms of its coverage of things that impacts the daily living activities in the days to come. So it has wide scope. You could find a path on your own in AI within that. Signboard recognition for driverless car. So I think this is more about, I don't understand this question very clearly, but it says signboard recognition for driverless car using artificial intelligence concept. So during our coverage on machine learning, we will look at 3 concepts of machine learning: supervised machine learning, unsupervised machine learning, and reinforcement learning. And within that, we will see how patterns are recognized. And maybe during that time, you would definitely find an answer to your query, or else we'll come back to you in our next interaction session. How can I use AI to build open source product as an individual? Now, the next question is very interesting. It says, how can I use AI to build open source product as an individual? This is something this course is aimed for. You kindly see that we are covering the fundamental concepts of AI in its totality, starting from problem solving using search. Then we have covered knowledge representation and reasoning. And then we will cover reasoning under uncertainty. And thereafter, we'll look at planning, and thereafter decision making, and finally we'll be looking at machine learning. So all these concepts can be used to make computational systems intelligent in some sense, and this should give you enough impetus for developing things that have AI in them. So are there any questions on live?
This one from Sanyama is well.
Is it possible to design any practical application in industrial AI without using machine learning, purely based on search methods or knowledge-based methods? Now, this is a very interesting question. Many people think that all you have to do in using artificial intelligence for the industry is some form of data crunching, or what we call machine learning. Now, for Sanya Maheshwari, the answer to your question would be that the A-star algorithm that I taught you in the search methods has been developed by Nielsen and from Stanford University. And the story about its development is that they have developed it for navigation of the robot that they have made, that I showed you in the history of AI, where I showed you the robot called Shaky, if you remember. So Shaky is a mobile robot that was made in 1970s at Stanford University. And in order to move Shaky from one place to another, they had used algorithms of search that we have learned. So here is an application that directly uses the A-star algorithm for moving from one place to another, an intelligent and navigator that's not based on machine learning.
Difference between AI and machine learning.
And which one?
Vijay Kumar and Rajesh Kumar.
And now Rajesh Kumar has a question who says, what is the difference or connection between AI and machine learning? So when I would introduce the module on machine learning, I would have already told you this. But now that you have raised the question, let me make it clear that machine learning can be seen as a subset of AI. So AI is more a broader term. Within that term, we can see machine learning. How machine learning can be seen as a subset of AI? I will talk of this during our coverage on machine learning. And then another term that's very catchy today, deep learning, actually can be seen as a subset of machine learning. So within machine learning, we have deep learning, and within AI, we have machine learning. So that's the connection between machine learning and AI.
School of Engineering. So now AI we apply to core branch like civil engineering.
What do you mean by Dean School of Engineering? Dean School of Engineering where? So the next question here is somewhere saying how AI can be applied to core branches like civil engineering or mechanical engineering. Now, this is a question that comes very often whenever we are talking of systems that deviate from the traditional modes of looking at things. So, for any traditional problem solving that you can think of, you can also think of out-of-box solutions for those problems. And AI provides you another mode of looking at it. So AI cannot be the panacea for all odds. It is not the solution that you cannot arrive at in other ways. But what AI can provide is another perspective or another out-of-box solution for problems that may have difficulty solving in conventional methods. Like, for example, in things like design, in things like a planning, where you have a lot of variables involved, a lot of constraints involved. You may have problem designing or doing planning under a constrained environment and using a traditional method. In such scenarios, you could apply techniques that we have been talking of within this course of AI.
Books to be referred for the course.
So for books to be referred for the course, I have already circulated the books that we will follow, and you may kindly look up the MOOCs web pages, or what we will do is we will share it in the link where you can ask questions to us on the MOOCs or SWAM website.
Prerequisite for AI learning.
As for the prerequisite for learning AI of the type that I am doing here, all we have said is that you must be aware of linear algebra. That was what we have wrote it in the web pages, and that is what it remains. For bone remodeling, that's mechanical. How can I use AI for bone remodeling? Now, to answer Ankush Pratap's question on how I can use AI for bone remodeling as a mechanical engineering student, uh, I will definitely come back to this question. And if I do not, please remind me and send me a mail when I cover machine learning. We will be looking at such stuff about getting to a description of a system where we have a lot of missing data when we do this module on machine learning. So I will reserve that answer to that point. So is it possible to design any practical application in industrial artificial intelligence without using machine learning? Same question, so it's repeated. So how can AI be linked with cognitive science and rehabilitation engineering? You people can answer this. How can AI be linked with AI? So yeah, this question from Priyanka Yadav on how AI can be linked with cognitive science and rehabilitation engineering is important from the fact that now with the advancement in electronics and the computation power are becoming more cheaper, it is an onus on us to really look at these electronic or electromechanical systems and build artificial intelligence into them so as to really help people who have lost their ability to, for example, move their arm or have lost their arm for some reason because of amputation. So in order to do this, we could do a lot of signal processing. We could do a lot of very efficient optimal control of the electronics. And at the very base of this lies the concepts of machine learning and artificial intelligence. Now let me try to explain this to you with an example. I'll particularly for people who have lost their, let's say, extreme upper limb. If people have lost their extreme upper limb and we are interested in putting a prosthetic device here, then we would need to draw, and let's say we want to control it using some form of biosignals, either coming from the muscles or coming from the muscles and the brain itself. Then you will realize that first I need to do here what is called recognition, or more specifically a pattern recognition of the signal that comes for the different types of grasp that I want to do. And that we do by machine learning in system, either supervised or unsupervised, that we will learn in our machine learning module. And then there is other forms of things, like you want to correlate the brain signal with the muscle signals here, because brain commands come and this person has lost his ability to really move his arm, but you want to make him move his arm, so you want to do some training on him on using some exoskeleton. So under such scenario, you really need to do again some form of signal processing, and then you want to create artificial intelligence systems that would take the minimal from the brain signals, the minimal from the muscle signals, and create what are called optimal control systems to arrive at things like bionic reflex. Like if you're holding a bottle and suddenly you see that the bottle is slipping out of your prosthetic hand, you want to regrasp it with more strength. So these type of things can only be done if we have a really intelligent controller sitting on top of the electronics. How can we apply AI aggressive environment like sewer cleaning and hill road construction? So Abhishek Rajkumar, thanks for clearing my doubts, sir. Rajesh Kumar, how AI will help to mechanical engineering? Can you please repeat again? So this question now, how can be applied in aggressive environment like sewer cleaning and hill road construction? So in order to answer this question on civil engineering, I think there is a corollary to that question now, where the Dean School of Engineering is asking about, for example, how can we apply AI in aggressive environments like sewer clearing and hill road construction? I suppose the best answer would be here without being very aggressively technical, is that you could think of creating intelligent embodied agents like robots. Those are mobile robots that can go about doing the task. So you would need an AI system in that, because then that mobile robot would need to do what we call the sense, plan, act activity in a cycle. So it should be able to sense the environment. So it would require a lot of sensors in your or mobile device or mobile robot that you're making. And then you need to have a lot of planning devices, planning algorithms. And it should be able to plan what is the next best action there. So it would be sensing and then planning and acting on that environment. So for acting, you need a lot of actuators. In the case of a sewage cleaner, you may need pushers, you may need excavation devices and things like that. So I think possibly that is what you meant when you said how to create one. So the only thing I can see is you can create an embodied agent that would do sense, plan, act in that cycle.
AI sense methods in comparison with traditional optimized methods.
Complex optimization, yeah, that is a nice question. When AI sense method preferable in comparison to tradition, that is a good method. So apart from answer question, so I could write the answer immediately. So is there any other question there? So let us see if there are new questions. Otherwise, we'll get back to the person who have repeatedly asked, because we should not leave people out. So our respected sir, greetings for the day. Sincere thanks. Is coding different from AI, and how can differentiate AI and ML from application point of view? Are we going to introduce further advanced courses in AI in the upcoming sessions in phase-wise manner for those who have completed the course in fundamental? So here is a long question from Aniruddha. So his question is about, is coding different for AI and machine learning? Now, as you can see, we have been talking of different algorithms. When I was doing problem solving research, we looked at different algorithms, and we looked at algorithms like A star, AO star, and now when we were doing planning, we spoke of graph plan. And then when I was talking about utility theory and reasoning under uncertainty, we had looked at another couple of examples on coding in that people could take up. And now when I do machine learning, you'd realize that all of machine learning could be divided into either supervised, unsupervised, or reinforcement learning. And depending on that, we will have three approaches to how you could code up a machine learning problem. As far as coding is concerned, the grassroots level similarity would remain, but the approach to tackling the problem would be definitely different. So that's the difference in terms of coding. And then I think I have answered his second question, how one can difference AI and machine learning. And then for his third question, which is about, are we going to introduce further advanced courses in AI in the upcoming sessions in phase-wise manner for those who have completed this course in fundamentals of AI? Now in NPTEL, as far as I am aware of, there are a number of AI courses floating around. Now this course, Fundamentals of AI, is for people who have not been introduced to the area of AI. So as of now, we have not planned for any advanced courses as a sequel to this. But then it all depends on how this course goes. If there is a lot of interest, we may take this up for our future. Doing research in the field of these techniques to solve problem of controlling auto ignition, KNN model and mission. What module of your lecture should I focus more to understand this concept? Now there is a question from Aditya Singh, which says that I am doing research in the field of HCCI engine, and there is a technique to solve problem of controlling auto ignition using AI. Also, artificial neural network models can predict the performance. Now, what module of your lecture should I focus more to understand this concept? As a teacher and as a person who is delivering this course, my answer would be that you should focus on all the modules equally well, But then on a serious note, to answer your question on what module would be relevant to the work that you have put down there about forecasting or predicting performance and using ANN, I would say our machine learning module would be what you would be looking forward to in order to understand how unsupervised learning or reinforcement learning can give answers to your questions. So this portion of the things are done now. So we can focus here if there is something.
AI and chemistry.
Application of
AI and chemistry.
AI in chemistry. So there is a question from Devraj Mysore Ramaswamy, which is about, has AI been applied to chemistry? Now, this question I have actually answered when I was delivering my lecture on production systems. Particularly, I had emphasized on the fact that decomposable production systems, if you remember, where you have a certain initial database, you break it up into smaller databases, you solve the smaller ones, and you get the answer to the bigger question, has been applied for understanding molecular structures in chemistry. So yes, AI has been applied in chemistry. Not only that, there are other examples of AI where it has been applied to chemistry. So I think this question, and you should look out for the answer to these questions when we are doing the course. One, I have already specified when I was doing decomposable production systems.
AI science methods versus traditional.
AI sense method. Now coming back to Sanya Maheshwari again, we have answered one of her questions. So this is our second question. For optimization problems, when are AI search methods preferable in comparison to traditional optimization methods like convex optimization or linear programming? Now this is a very interesting question. When do you choose one vis-a-vis the other? My only rule of thumb at this point of time would be when you do not know much about the problem at all. So when we were talking of things like searching for the best first move, when I am playing a game of chess, where I do not know much of the problem, what is going to happen in the future, then the best first move I would take by that idea of minimax, if you remember, by just looking at a two-ply depth and then backing them up and deciding about the best first move. So these type of things is when you will use AI search methods rather than traditional optimization, because it would not be possible to completely have the tree first and then look for a solution which is the best. Which programming language is required in AI is by Priyanka Yadav. So Priyanka, the programming languages that you should look for depends on what portion of AI you are doing. So for things like the problem solving that we have done in terms of problem solving a state space search, you could use any programming language like C, C++, whatever you fancy. But for things like the stuff that I am covering right now in the module, which is inference in first order logic, and then we are talking of finding out proofs of things, I would love to see people use Prolog programming, which is programming in logic, and then you could have Lisp to look at, and then when we are looking at machine learning, the most popular one right now seems to be Python. But that does not stop you from doing machine learning in any other language for that matter. So do we have a simple practical example in the course which correlates how algorithms and systems are constructed? This question by Chetan has made me think seriously. He has written that, do we have a simple practical example in the course which correlates how algorithms and systems are constructed? So definitely I will take this up when I talk of planning in the subsequent module. As of now, I thought we were talking of algorithms only after I had given you the example. Like first in the problem solving and a state space search, we looked at this complex problem of state space by a very simple example of 8 puzzle or a simple example of n queens. Okay, but that does not stop you from thinking that the 8 puzzle game could be replaced by a complex room or a cinema hall where a robot wants to move from place A to place B. As the cinema hall takes different states where the robot comes and sees the different rows. So we have looked at very simple problems and then looked at an algorithm involving them, rather than talking of a practical problem and then looking at the algorithm. In the next module that I do, I possibly would love to talk of the practical example first and then do the simple algorithm. I think that would settle his query.
Application of AI in metal forming.
Sir, I'm Dr. S.M. Jingasia from Bagalkot of Karnataka, where AI is applicable to metal forming. Now, this question from Sidhu Jigasanya, which is about use of AI for metal forming. I do not think I am very competent to really comment on how metal forming in AI could be applied, because I do not understand metal forming to a very large extent. But on a very abstract level, I can see that if you are talking of metal forming in where it is like different mechanical processes involved, parameter control or other characteristic control using different parameters like the speed the metal is proceeding in, the sheet of metal is being pushed in, or the pressure that is being applied. These sort of parameters could be well controlled by an intelligent computational system. That is all I can say, because to talk of metal forming, I am not the competent person here. How to find probabilities for a question and these answers to connect with sensor input. How to find probabilities for a question. Okay, so possibly this question by Vijay Kumar are on how to find probabilities. We have discussed this when we were doing Bayesian network. So getting prior probabilities of a system is something which is really complex. You need to run the system and then really need to calculate these probabilities before you can really decide on what are the prior probabilities for a system.
Augmented reality and virtual reality related to AI.
So will it be possible for AI to apply all jobs that are open in internet with a keyword and a resume? Now this question on will it be possible for AI to apply all jobs that are open in internet with a keyword and a resume looks fancy. You create a resume and keep it in your computer, and then AI system will try applying for it. In principle, yes, but I'm not sure if such a system exists or one could be really made practical, because of the very fact that only string matching of your CV to the requirements of the job may not be what you are looking for. There will be other questions that's beyond string matching, and it would involve more complex questions, including questions that are not currently maybe computable in terms of a value that you assign. So many intangible things, and that is why having one that could apply for all your jobs may not be possible in the near future.